Okay, so if we scroll down to where we left off here, well, let's see here, what was it? This part right here. Example 3, we did not do this second one, so I'd like to do that. Okay, so again, maximum and minimum values of a quadratic are either our highest or lowest point on the graph. Now, if I look here at this second one, g of x, think about it, don't shout it out. Is this going to have a maximum or a minimum? Hannah, is it going to have a maximum or a minimum? Maximum. It's going to have a maximum. Why, Reed? Why is this going to have a maximum? Because it's got a negative in front. If it's got a negative in front, that means I know the graph is going to be opening down. So therefore, this is going to have a maximum. Okay, now how do we find our maximum? Or minimum, but in this case it's a maximum. Hannah?
It's the y value of the vertex.
It's the y value of the vertex, so we need to find the vertex. How do I find a vertex of a parabola that's in standard form? Well, let's go back to our graph. I guess I can't go back to my notes. You guys can go back to your notes. If you flip over the same note sheet, you flip over to the front side. Everyone flip over to the front side of their notes, please. It says standard form, and then it says axis of symmetry, which is opposite of b over 2a. And then the vertex is opposite of b over 2a, comma, f of opposite of b over 2a. Can anyone in their own words explain what that means or what we need to do? Maybe you want to give it a try?
Well, what we need to do is find the axis of symmetry, and we got to plug that number that we get in for all x's.
Excellent. So we need to find the axis of symmetry. To find the axis of symmetry, it's the opposite of our b value over 2 times our a value. Now let's recall here, what's our a value here? I'm going to write it over here. I don't know if you guys have room over there or not, but what's our a value here, Rachel?
Negative x.
Careful.
X squared. -1.
-1. It's just the number in front of x squared. So in this case, it'd be negative, which is -1. Our b value here is going to be 5, and our c value is 9. Okay, so opposite of b, which is going to be -5, over 2 times our a value, which is -1. So I'm going to get -5 divided by -2. That's going to be positive 2.5. What's that tell me?
That is your x.
That is your AOS.
That's my axis of symmetry, my AOS. Cole, would you say?
The x.
The x of?
Your vertex.
That's the x-coordinate on my vertex. That tells me where the vertex occurs as far as left and right, what x value, but now we want to know how high or how low our vertex is. So therefore, we're going to plug 2.5 into the function. So now I'm going to do f of 2.5. Now, whenever we get fractions, it could potentially get a little bit different. I'm going to have negative times 2.5 squared plus 5 times 2.5. I'm going to run out of room here. Plus 9. I'm going to erase it. Start over. F of 2.5 equals negative 2.5 squared plus 5 times 2.5 plus 9. Okay, how do I do this with this negative here and squaring it? How do I think about that? So I've got this negative, and then I get 2.5 squared. What do I do? Do I times it by a negative? Distribute the negative? Order of operations. Please excuse my dear Aunt Sally. Parentheses first. There's nothing to do in parentheses. Then we go to exponent. So help me out. What's 2.5 squared? 6.25. Then I need to times it by -1. So negative 6.25 plus, what's 5 times 2.5? 12.5? Is that right? plus 12.5 plus 9. So now I'm going to take negative 6.25 in my calculator plus 12.5 plus 9.
15.25.
We agree with Cole there, 15.25. That is my maximum. 15.25. Okay, I'm just going to sketch this. I don't think you guys can do that over here. There we go. So if I just briefly sketch this, where's my axis of symmetry at? 2.5. 1, 2, 3, somewhere between 2 and 3. Where's my maximum at? Well, it's way up at 15. So I'll just briefly do that. This point right here is the point 2.5, comma 15.25. Okay, so now we got to answer all these questions. Domain. Domain talks about x or y?
X.
X. So which x values are we using here? Rachel?
Would it be 2? No, just, I don't know. It's something infinity, right?
I don't know, is it?
Yeah.
So if I look at my arrows, are these arrows ever going to stop?
No.
Are they ever going to stop going down? No. Are they ever going to stop going out?
No.
No. Here's the trick. If it's a quadratic, if it's x squared, the domain will always 100% of the time be all real numbers. Meaning you can plug in any x value you want, any real x value into the function, and you're going to get an output.
That will equal, that all real numbers things equals for maxes and minimums as well.
I believe over here we had negative infinity to infinity on this problem, Cole.
Yeah.
That's the same thing as all real numbers. So it doesn't matter if it's a maximum, it doesn't matter if it's minimum. It doesn't matter. As long as it's x squared, the domain is always going to be all real numbers.
Are there problems like this where you do that on x squared?
We'll get there, yes. We'll get there as we keep going out through our entire class, and we'll investigate, hey, when isn't the domain all real numbers? Okay? Now, the range. The range talks about our y values. We'll say this. What's my lowest y value?
There is
It never stops, right? Those arrows are going to keep going forever and ever and ever. So my lowest range is negative infinity. Infinity's up, negative infinity's down.
to 15.5.
What's my highest number? 15.25.
Why wouldn't it be switched to?
Because we always go low to high. The lowest number's first, then the highest number.
Okay.
That's a good question.
Okay, but I don't get like when is it a bracket and when is it a parenthesis?
Okay, that's a good question. When is it a bracket and when is it a parenthesis? We can never get to negative infinity, right? So we're actually, what we're thinking of that is, it's not including negative infinity. We're never going to get there. Okay? So let me draw this up here just for a second. Let's say I'm going to make something up here. Okay? Is the graph at 15.25? It is. There's a dot there. There's a point there. So therefore, we're going to have a bracket. I talked about that real briefly in chapter 2. We're going to keep kind of talking about it all the way through. They'll use it a bunch in pre-calc next year. Okay? The next idea is, hey, where is the graph increasing? Meaning, where is the slope positive? Where's it going uphill? Would you guys agree it's going uphill on this part of the graph?
No.
Isn't that going uphill from left to right? We're always going left to right. That's going uphill. So we're increasing from which two numbers? Well, we're going to start at negative infinity because, again, the graph never stops. So from negative infinity all the way until we get to what number? Careful, we're talking about x values now. Where are we increasing? It's 2.5. Okay, so we're increasing in our x values from negative infinity all the way up to positive 2.5. Now, are we increasing at 2.5?
No. No.
We are not increasing. At 2.5, it's the top of the hill, if you will. We're not increasing, we're not decreasing, it's 0. So when I say 2.5, am I including 2.5? No, therefore we need to have a brass parenthesis instead of a bracket. Okay, now we are decreasing from, what's our smallest value, our x value that we're decreasing? Yeah, 2.5. Well, Liam, are we including 2.5 though? No, because again, 2.5 is the top of the hill. And we're going to be decreasing until, not negative, but now this time positive infinity. Because negative infinity is way over there, positive infinity is way over there. Questions there? There were, I think, 4 problems on our homework that involved this stuff. Okay, I want to make sure you go back and check those if we've already done them. Check those, make sure we've done them right. And I actually have 2 more for you on today's assignment. Okay, now our last form. We've got a vertex form. That was our first form of a quadratic. Then we added standard form, and now this last one's called intercept form. Okay, our intercept form is like this. A times x minus p, x minus q. Now guys, when we were in vertex form, it was very easy to find our what? Axis of symmetry and our vertex. If it's in vertex form, we're able to find our vertex. Okay? Well, if it's in intercept form, x minus q is what that is. If it's in intercept form, it's going to be very easy to find our intercepts. Okay? And here's what our intercepts are. Our intercepts are, I think I want to write this. I'll do p in q. Now, these are our, maybe you should put here our x-intercepts. Do that for me. X-intercepts. Now, if we have an x-intercept, what's the y-coordinate? 0, right? So really, this tells us that our our intercept here is going to be the point p, comma 0 and q, comma 0. Okay? Now, I'm going to go down here and do as much of this as we've talked about so far. So here we go. I have a function in intercept form. Okay? How do I know it's in intercept form? Well, it's got 2. Does this look familiar? Where have we seen that before? Great, last chapter we talked about factoring, absolutely. When we talk about factoring, that would be a potential answer. And I heard Tristan say FOIL. Well, if we FOIL, we're going to get something that ends up being in standard form. Okay, so if we FOIL this, we're going to get standard form. Okay, now, our intercepts are, I'll just say this, they're the opposite of these numbers. They're the opposite of them. Okay? Because you think about, let's go back to vertex form. In vertex form, we have h that's in, we have h that's in parentheses, and we always say that h is a liar. Well, basically, the same applies for p and q.
P and Q are liars.
P and q are liars. Both of them. So our x-intercepts here then are going to be at what? -3, 1, 2, 3, and +1. -3 and +1. Now, Mary Beth, is the graph going to open up or open down?
Down.
It's going to open down, right? So, we know to be true that a parabola is going to have an axis of symmetry. Would you guys agree with me? Now, where is the axis of symmetry going to be located relative to those 2 points? Cole?
Middle.
Right in the middle. Right in the middle. Our axis of symmetry is going to be right, let's see here, there's 2 units, there's 2 units, we're going to be right here. Going to be in the middle. Now I think that's pretty straightforward. Now we do have a mathematical way to figure that out. Our axis of symmetry is going to be x equals, guys, if I want to find the average age between Marcus and me, how do I do that? Add them together and divide by 2. That's what we're going to do with P and Q. We're going to add them together, P plus Q, and divide that by 2. So that tells us our axis of symmetry. It's going to be x equals that. Now, if I go down and apply that to this problem, well, I'm going to have x equals P plus Q divided by 2. Well, I'm going to have -3 plus 1 divided by 2. What's -3 plus 1? -2 divided by 2 is -1. So x equals -1. Now that's what we already had drawn in there. Now, where is the vertex going to lie? Where's the vertex always lie?
On the axis of symmetry.
Highest low point on the axis of symmetry was the answer I was looking for. It's always going to be on the axis of symmetry. So here's what we're going to do. Once I have my axis of symmetry, I'm going to plug in that value into my function. Okay, into that function. So here we go. I'm going to plug in, I'm going to do -2 times, I'm going to plug in -1 for x. -1 plus 3, and then -1 minus 1. So in my parentheses here, what's -1 plus 3?
2.
That's 2. What's -1 minus 1? -2. And what is, I'm multiplying those by -2. So what's -2 times -2 times 2? What's -2 times -2? Negative times negative is a positive. +4. And then what's +4 times 2? 8.
Wait, you do negative.
It doesn't matter which order you do them, Cole, but I like to do a negative times a negative because then that gets rid of my negatives.
Okay.
So if you do -2 times 2, well, that's -4. -4 times -2 is +8. So that tells me my axis of symmetry, excuse me, my vertex, I should say, my vertex is at 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. Guys, if it's in vertex form, I'll live with 3. I'll live with 3 points. There we are. Any questions there? If I recap, well, plot our our x-intercepts first. Opposite of that number, -3, -1. Excuse me, -3, +1. I then know my axis of symmetry is going to be directly in the middle I put that in there at -1. I plug -1 in to figure out where my vertex is. Okay? These are the same ones, aren't they? Let's change this. Let's do f of x. Let's see here, equals. Let's do...
For the
Okay, let's go back. So our vertex is p plus q over 2, meaning, meaning, have your head up, Marcus. Thank you. If you lay it out, sit up, please. Sit up. Thank you. Our vertex is always going to be on the axis of symmetry, so that value has to be the same for our x value of our vertex, and then we're going to do f of p plus q divided by 2, meaning, hey, we're going to find our axis of symmetry first, p plus q divided by 2. Whenever number we get there, we're going to plug that into the function to get the y-coordinate of our vertex. Okay, here, this next one, I want to have you do this on your own. You're going to have x. Go. Okay, guys, the easiest way, and I've already got some people asking me, is this right? Was this wrong? And I think they already know the answer. The easiest way to check if you've graphed this correctly, and not 100% correctly, but you're at least you're on the right track, is whether it's opening up or opening down. You should never have a graph or leave a test question, okay, where it's opening up and you know it's a negative a value, or vice versa. So in this case, I know it's going to open up because I have a positive a value. So I already know my x-intercepts, that's -4 and +1. Okay, so when I go to find my x-intercept, or my axis of symmetry, what have we noticed? It's not going to be a whole number. That's fine. That's okay. Just to make sure, I'm going to say x equals p plus q divided by 2. So our p value is -4. My q value is +1. Notice how these numbers are the opposite of those. Divided by 2, I'm going to get -3 over 2, which equals -1.5. That means my axis of symmetry is at -1.5. Now, how am I going to find my vertex? Plug that in. We're going to plug 1.5. I'll do it down the room down here. Perfect. I'm going to do 2 times, help me make sure I do this right, -1.5 plus 4 times -1.5 minus 1. So this is f of 1.5. So here we go. I'm going to have 2 times, what's this going to be? That's 2.5. And this is going to be -2.5. So we'll do 2 times 2.5 times -2.5. Then what? -12.5. Do we agree with Liam there?
Yeah.
Okay, so I'm all the way. It's negative. Oh, so I'm down here. -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to be off the graph a little bit, but we'll get it pretty darn close. And there we are. Questions on that? Okay. Last problem says this. The parabola shows the path of your first golf shot, where x is the horizontal distance again in yards, and y is the corresponding height in yards. The path of your second shot can be modeled by the function. So understand this. This is our second shot. This is our first shot. The second shot is modeled there. First shot's here. Which shot traveled farther before hitting the ground? Well, how far did this fall or travel before it hit the ground? Now, I'm just saying, if this is in yards, you think this is drawn to scale?
No.
And you'd probably be like 75 yards tall. Wow. That's ground.
It's possible.
So, how do we, it says which shot traveled farther?
Sorry, come again?
Which shot traveled farther?
I don't know.
Let's stop here. Is this function, is that in standard form?
No.
Is it in vertex form?
No.
Or intercept? I mean, which form is it in?
Combination.
It's not a combination.
Is it intercept?
And is it intercept? Why are you questioning intercept?
Because it's not looking the same.
What do you mean it's not looking the same?
There's no Q.
Okay.
There's two X's.
Now, guys, if I rewrote this thing so it said f of x equals negative 0.02 times x minus 0 times x minus 80, now what does that look like?
Now it's looking like intercept.
Now it's looking like intercept, right? I've got two sets of parentheses. But notice how, if I've got plus 0 or minus 0, do I need to put that? No. So if I have an x like that and then an x minus 80 in this case, that's saying, hey, it's in vertex form, but one of our intercepts is 0. Now, does that make sense to the problem?
Not really.
Why not, Tristan?
Because it's confusing.
Does it make sense to the problem that we have one intercept at 0?
Yeah.
What's Sam? If I hit a golf ball, isn't the golf ball starting at 0
Yeah.
feet from me? The x-intercept is 0. Right? And if I take a look here at this picture, I know that this is a golf shot. It's not that function, though. What's the x-intercept? 0. That makes sense. Of course it does. The path of the ball has to start on the ground. Okay. So which one traveled further? Or farther? I don't know. Is it further or farther?
Further.
Farther.
Which one went longer? This is the first one.
Oh.
Whoa.
Private accordion.
The picture is the first one. The function is the second one. Which one went further?
The second one. Or the first one.
Oh, yeah.
Figure it out.
Here's the first one. Here's the second one.
Let's go figure it out.
Intercepts.
Hannah, nice and loud.
You just look at the intercepts.
All you do is look at the intercepts, guys. This one went how far?
100.
100 yards. This one went how far? 80 yards. The first one went farther. I'll put further. So if it's in an intercept form, guys, that's pretty darn easy. Look at the intercept, see what went further. Now, which one went higher?
Flash.
How are we going to figure that out? Which one went higher?
Plug it in.
The maximum height occurs where?
On negative. On the negative.
At the vertex. Would you agree the maximum height occurs at the vertex of a parabola? It's our maximum or minimum. That's exactly what we just got done doing, huh?
Yeah.
So if I find my maximum or find my vertex, then I can compare the y values to see, hey, which one went higher. So I'll do this one first. Well, I already know how high this one went. How high? 25 yards. So now I'm dealing with this guy right here. How do I figure out the vertex?
P plus Q divided by 2.
Okay, P plus Q divided by 2. That's going to be what? What's 0 plus 80?
80.
80 divided by 2 is 40. So I'm going to do F of 40. Because one intercept is 0, guys. If I were to make a sketch, one intercept is 0. The other intercept is at 100. That means right in the, excuse me, not 100, 80. That means right in the middle has to be 40. So negative 0.02 times x minus 40. Oop, I lied. I need to do 40 minus 0. Well, if it's minus 0, I'm not even going to include it, am I? So we'll do 40 times 40 minus 80.
32.
So I'm going to have negative 0.02 times 40 times negative 40. So what's negative, or 40 times negative 40? I'll do this one right here. So 40 times negative 40 equals negative 1600 times negative 0.02. Gives me 32. So this one went 32 feet in the air. Which one traveled further? First one's the picture, second one's the equation. The second, excuse me, not further, higher. 32 versus how high did the other one go? 25. This one went 32 feet in the air, that one went only 25.